When we're given a description of a linear relationship or an equation, we can use this information to fill out our table of values. So in this situation, we have a car traveling at a speed of 100 kilometers per hour. So if we travel for 5 hours, we have traveled a distance of 500 kilometers. So we have to take the 100 and multiply it by our time. If it was t equals 3, so you have 3 hours we've traveled, then 300 kilometers is the distance. So we can put that into an equation as d equals 100 times t. Take the time and multiply it by 100 to get the distance traveled. Okay, so let's put this into our table, this information. If you travel for 1 hour, 100 times 1, because remember 100t means 100 times whatever the time is. 100t, where t is 1, is going to be just 100 times 1. If the time is 2 hours, we're going to do 100 times 2, which gives us 200. And then we're going to do 100 times 3 for the next distance. So 100 times 3 hours gives us 300. And finally, we're going to take 100 and multiply it by 4 hours to get a distance of 400 kilometers. So the points, remember that t here is our independent variable. Our distance depends on the time, so we're going to plot that along our x-axis or our horizontal axis first. So when t equals 1, we're going to plot a distance of 100 on our y-axis or our distance axis. The next point would be 2, 200, 3, 300, and finally our last point is going to be 4, 400. So I'll just show you how to plot these on our graph. So what you would do is to plot 100, you would go over on your horizontal axis to 1, and then you would go up to 100. So this would be the point 100. For 200, you would go over to 2 on the horizontal axis, and you would go to 200 on the vertical axis, and where those two lines meet, that would be the point 200. So you can plot your 4 points on our graph, and then I'm going to take my ruler and I'm going to draw a line of best fit. Okay. So once I've done that, I'm hopefully able to use this graph to, given a time, figure out a distance. And I can do this for information that's given or information that I find sort of between the points. So in these areas here, between the points that were given in the table. Or I can extend my line in either direction and I can find out information over here. Okay? So when you're looking between the points that are given, we call this interpolation, inter meaning in, okay? And extrapolation is beyond, so that's when you extend your line beyond, okay, the points that are given. So use interpolation to find the distance traveled in 1.5 hours. Well, 1.5 hours is between the points 1, 100, and 2, 200. Because they're in between, we call this interpolation. Okay, so what you're going to do is you're going to go to your x-axis or your horizontal axis, the time axis. You're going to go over to 1.5, which would be here, halfway between 1 and 2. So you're going to trace over there, and then you're going to trace up to where the line crosses the line that you just drew. Okay, so one more time, you're going to go from 1.5, you're going to go over to 1.5 and up to the line that we just drew. And then we can read off 150 kilometers. And it's actually good to show that on your graph because it shows your thinking. So you can just leave that right on there. So we see that that happens at 150 kilometers. Okay, extrapolation, remember, means beyond the given data. So 4.25 hours was beyond where my table ended. So 4.25, if this is 4.5, 4.25 would be here. So I'm going to take my line, vertical line, straight up to here. Okay, and then I'm going to trace over. There we go. And it's going to cross the y-axis, the vertical axis, at 425, it looks like. So 425 kilometers is my answer. All right, we can also work the other way. We can be given a distance, and we can figure out by tracing backwards what the time or the independent variable is. So our distance is 350 kilometers. So this time we're going to start with the dependent, the vertical axis. 350 would be here. I'm going to trace over to my line and then down to where it hits the x-axis. So that's at 3.5 hours. And we call that interpolation because 3.5 hours was between 3 and 4 hours. And we had both of those points found in the table. Okay, both of those times were found in the table. Extrapolation means we're going beyond. So 80 kilometers was not one of the values that was in our chart. It was lower than 100, which was our lowest y value that was in our chart. So we're going to have to actually extend our graph back this way to see that information. So we're going to go over to 80. So this is 50, this is 75, so 80 would be about here. And this time we're just going to have to approximate just a little bit, and then we're going to trace down. So to me, it looks like if this is 0.5 hours and this is 0.75 hours, that looks like 0.8 hours. Okay, so that's how you use interpolation and extrapolation to read information off of a linear relationship, a graph of a linear relationship.